Hello everyone, my name is Richa Singh from CSIT department. I'm assistant professor over here. Today I'm going to discuss on about convolution neural network of subject machine learning of CSIT 6th semester branch. So today's my topic is all about the introduction portion of the CNN. Here I will discuss you about these are the some important topics like introduction, CNN architecture, training process. Let's go forward. Before going to start my CNN, what exactly it is, we have to understand what is the traditional work of AN and why we go and adapt against the CNN. Like, what is the problem behind the ANN architecture? That's why we have to know. So, after knowing that the traditional ANN architecture problem, then we will forward about the CNN, which full form is convolution neural network. Here, the traditional artificial neural network becomes computationally expensive. Mm. Why? When dealing with high dimensional range, like high dimensional image data, so CNN overcomes this kind of issues through local connectivity, weight sharing, feature extraction using convolution operation. CNN automatically learns important features from images without requiring manual feature extraction. So here, the artificial neural network have that kind of computationally expensive issues arises. Thereafter, we have to go and invented the new concept about convolution neural network. So now let's start with our main topic, which is convolution neural network, which is a specialized type of deep learning algorithm primarily designed for processing structured grid data such as images. CNN are inspired by the working mechanism of the human visual cortex and are high effective in recognizing patterns, shapes, textures, and objects within images. CNN widely used in image recognition, face detection, medical image analysis, autonomous vehicle, and video analysis. And thereafter, here we can see how CNN work. You can able to see a simple input image in my screen, and thereafter the second image comes in the form of their different operations which are involved in convolutional neural network. So first operation is operation, and then pooling operation. It comes with the activation functions, which is ReLU. Why we are using here ReLU activation function? Just because ReLU has that a range from started from 0 to infinity. Like, we don't want to capture the negative features, we only want to focus on the more positive features. So like here in the input image, there is a zebra image. So here is the kernel, which means a filter is applied to the leg of the that image of animal, which we need to extract what exactly is it, this animal, like it is a zebra or maybe horse or maybe different another leg of different animal. So actually we want to predict that this image is exactly which animal. So by using the convolutional pooling layers, then the next layer is flattened layer. It means by different kind of deep and pattern parameters and depth which is coming after the pooling layers, after the feature selections, the flattened layer work is to convert all these depth into one dimensional, then a fully connected layer. Here you can able to look with what exactly the fully connected layer. Basically, it is an artificial neural network. It is a traditional artificial neural network, but in before going to that traditionally fully connected layer, we have to do that kind of different operations. Like we have to initially do convolutional neural network, then pooling operations, then flatten layer operations has been completed, and thereafter the final output we will achieve, like you can able to see 0.2% of probability of horse, 0.7 probability of zebra, and zero point 0.1 probability of dog. By using the filter of applied in the leg of the zebra, we by using the softmax activation function in the output layer, we get these probabilities. So the probability of that higher probability selected as our output. So here the zero point 0.7 means 70% probability is predicted by the machine of convolutional layer which shows zebra is the actual image. So here our main work is to extract the feature from any input image. So here in this process, we get to know that how we extracting the feature of any image by use applying the filters. So now I'm going to just show you how the process is working here. So here in this way, we are able to understand how the convolutional operation has been performed. So here you are able to see that by using I have a simple image of a two numerical digit is kept over here. Here, a filter of 3 by 3 is applied on that image by using that by using that filter of operation of matrix operation, which is the multiplication summation operation has been completed, and thereafter we are extracting the feature. So at the output image, you are able to see there are two different kinds of image pixels are you getting. So here there are red and blue. Me, what exactly it is? Red means more positive, blue means negative. Here we need to leave that negative sections. We have to only capture on the positive section. So here we are extracting and we are only focused on the positive section by applying the ReLU activation function. All the positive negative features like the blue section will be considered as the zero. Zero means there is a nothing. So also I also want to get to know about this too is that there are two different types of channels of an image. Like there is a grayscale channel or which is one channel, single channel image. It has only black and white color. Black means zero, white means one. So that kind of gray image are already provided you in the video section. And the other one is RGB, that means three channels, red, blue, green. And there's a three channel image. Uh, so there are basically two types of images, and their pixel rate is from 0 to 225, 255, not below zero or not above 255. And this is the process how each and every step has been performed. Like we have 5 by 5 input image. One section means white and zero means black. Convolution layer has performed feature extraction. Pooling layer has performed the downsampling, which means if we have a more feature pixel image, we have to just reduce the dimension of that particular image. Then we will use the pooling layer. Flattening means just converting again, dimensionality reduction by converting 2 by 2 pixel image into one dimensional. That means single node, which is stored some value. And that these single values is we will provide them to the fully connected layer. And here we are getting the output in the same way, which we known as also as classification. So real world example of convolutional neural network, we can say that a medical image classification where we need to detecting a brain tumor from MRI. I have a black and white grayscale image of brain, which is MRI scan of 2 to 4 into 2 to 4. That 2 to 4 into 2 to 4 means there is a height and width. Actually, the height and width of that image is 224 by 224, which is a 2D grayscale medical image, and that image is given to the convolution layer. And here the convolution layer has to perform the feature extraction of that brain MRI scan, and thereafter we have performing that pooling layer, which means a downsampling, and after that we will same way provide these images for converting them into one dimensional vector process, and then fully corrected layer classification, which means tumor or no tumor. So here the prediction of tumor is 0.97 and no tumor 0.03. 9.97 means there's a probability of having the tumor of that MRI scan is zero point 0.9. That means 90% of probability that the brain or MRI image of a brain consisting the tumor. These are the some applications apart from medical image like object detection, face recognition, and image detection, medical image analysis, autonomous vehicle, natural language processing. In agriculture, also CNN plays a crucial role, and industrial automation. These are the main real world examples of CNN where these CNN algorithm is basically used in machine learning. So thank you for this session. And now I'm winding up.